my talk is called Down the Rabbit Hole. It's a little story about a crazy bug I was chasing around for 2.5 months earlier this year. My wife, I came home from work for like 3 days in a row. My wife asked me what I was doing at work. I said chasing a bug. And finally she was like, why shouldn't you be working? Why are you chasing a bug around the office? It's like, no, never mind. So this is like a little play, sort of. There are 6 acts. I have a cast. I am in the cast. That's me. That's what I look like on the internet. I work for a company called Olark. We put live chat on websites. So there's usually a little chat box in the lower right-hand corner. You might have seen it around. It's popular among the startup community. This little bird is going to help give advice throughout the talk. And this is the app that had the bug. It's a Node.js-based app that allows our operators to chat with the visitors on their website from their web browser, so they don't have to download any software on their computer. It's basically a Jabber client that runs in your web browser. It's built on Node.js and Socket.io, among other things. All right, so let's get started. Act 1 is denial. A few months ago, a customer came to me and said, the chat client keeps disconnecting and reconnecting. I said, my code is perfect. There's no way that's happening. It must be your problem. For those of you who don't know what pebcac is, it means that the problem exists between the keyboard and chair. This is my problem that often exists between my keyboard and chair. Anyhow, it's basically just user error. Well, then a couple days later, another customer came to me and said, hey, the chat client keeps disconnecting and reconnecting. Yeah, it's still user error. Maybe. Maybe it's just a crappy internet connection. A couple days later, one of my coworkers came to me and said, hey, my chat client keeps disconnecting and reconnecting. It's definitely user error this time. Just kidding. Sorry. But he did say, hey, my internet has been flaky lately. And so I said, sweet, flaky internet. Problem, I thought so. So problem solved. Get better internet. It's the end of my talk. No. Just kidding. So first piece of advice from the Olark advice bird is to listen to your users. They actually use your app probably a lot more than you do, so sometimes they actually are telling the truth. So on to Act 2, acceptance. Fine, there is a bug. So I wonder how often this bug is happening. Like if it's just 2 people and my coworker, then okay, maybe it's not super high priority. But if it's like everybody, then all right, we should probably fix it. So my first instinct is, all right, let's go. Let's look at logs. We have logs. Logs. They're big. They're helpful. They're text. Logs. And ours happen to be in JSON, and they have hashtags in them, because that's just what we do. So we actually were logging an op_disconnected hashtag every time someone disconnects. So if you stuck this log, or if you graphed every time someone disconnected, it looks something like this, peaking around 30 or so per minute. If you look at our total connection graph, it's roughly in the 350 range at a maximum. So if we have a maximum of 350 connections and disconnects around 30, that means 10% of our users are disconnecting every minute, which is actually like, fine, it's a problem. Yeah, great. Lesson number 2, And I'm going to lose count of these, so I'm going to stop counting. But graphing is really helpful. It only took a few minutes for me to figure out how many people were being affected once I knew to look, basically. And we have a lot of graphs like this for this particular app. Can you read that? Anyhow, these come in very handy. Like after deploy to check and see if everything has gone OK or if you've got a high error rate or whatever. I highly recommend having some dashboard with graphs on it for your app. Anyhow, let's go back to the logs. So this is a Unix system, and I know how to use this stuff. So let's take the log, look for all the op disconnects that happen in it. And this is not a standard Unix tool. But since our logs are in JSON, there's this cool thing called JSON tool that you should look at if you are in a similar situation. And you can basically pick out pieces of your JSON particular keys in the object and get rid of everything else. It's like, it's what you wish you could do with XML easily on the command line, probably. But anyhow, so this basically, up to this point, will give us a list of all of the usernames. Every time a username gets disconnected, it prints out their username. So if we sort it by username, and then count up all of the unique instances of that username, and then sort it again by the number, the count of that thing. Oh yeah, you need to do that if you want to actually run that. We'll get something that looks like this. It's like, in this log file, Steve disconnected once, John disconnected twice, and Susie disconnected 512 times. So, OK. Susie obviously is having something crazy going on. So let's go back to more Unix. OK. This slide is not working. There we go. OK, so get the disconnects again. This presenter tool thing has totally failed. This time we will get the timestamp and the username out of the JSON, and then filter just Susie's stuff, and take the first field, which is just the timestamp. So really all we're looking at is what are the times that Susie's client disconnected. And when I looked at this, I noticed this is happening almost exactly every minute, plus like a tiny little millisecond delta. It's going 445, 446, 447, and 448. So that's kind of weird. Like a minute is sort of a big coincidence, if you ask me. So the bird says, log things, because it's really useful to look at the logs and be able to figure something out without just like sticking in print statements or something. And also know how to use your tools. So you can take your logs, throw it through a thing. I mean, the command line, all that command line stuff took me a couple minutes to put together. If I had to like write some program to do that, it would take a lot longer. All right, so Susie's definitely having a problem. None of us, except for my coworker Sunir, had actually seen this on our computers, and we'd been using for a couple of months before we released it to any customers. So, but Sunir did say something that was interesting. He has Flaky Internet. So how can we simulate Flaky Internet and see if we can reproduce it somehow? I tried doing stuff with iptables. And about a half an hour, I said, screw it. And I unplugged my Ethernet cable. And I had Flaky Internet. Success. Unplug Ethernet cable. Wait. plug Ethernet cable back in, and it reproduced the issue. It got into the reboot loop and was doing all its stupid, annoying stuff that I wanted it to do. So the lesson here is just do something, like, at some point, if there's something stupid you can do that's going to work, when you're chasing a bug especially, I mean, maybe not when you're writing like nice production code, but but if you're chasing around a bug, like, just do what you need to do to figure out what's going on and worry about it later. Maybe also learn your tools later. Why is this thing not working? Okay. Anyhow, next act, trying to figure out what is actually going on. So I looked in Chrome's developer tools. You can read this, right? And so if you click on the Network tab in Chrome's developer tools, you can then click on the WebSockets tab down there, which will filter the list at the left for WebSockets. It's a very intuitive UI that filters that. And then if you click on frames, you can see each little bit of data that's transmitted through the WebSocket. It's very useful for WebSockets debugging. I figured it out about 2 days after I needed to figure it out. But in retrospect, very useful. But there's no close event that happens at the bottom. So the WebSocket just sort of stopped at some point. So I decided, OK, I'm going to figure out what's going on one way or another. And I got Wireshark going, and I TCP dumped a hello. Where are you? I guess I have to do this. All right. So this is a Wireshark dump of one reboot loop that happened. And if you look here, this is the WebSocket being forcibly closed on the client side. I happen to know that because I know the IP addresses. But Wireshark is like a super awesome tool if something is going weird at the protocol level and you have no other idea what's going on. The newest version can dissect WebSocket stuff, so it'll tell you everything that's being sent through here. In the payload, it knows all this stuff, so it's 5 : name visit blah blah blah. This is the data that's going across the protocol, and it's really really helpful for when your logging and stuff is not enough, and Chrome Developer Tools is not enough to figure out what's actually going on. So check out Wireshark if you got some really weird protocol thing going on. So anyhow, I looked at that, and basically what it told me is that the client side was what was closing the connection. It was not the server dropping it or kicking anyone off. So at that point, that's a small amount of useful information. At least I don't have to mess around with the server side. And thanks, Chrome, for not telling me that the client side was the one that was closing the connection. So I just decided to do what I call shotgun debugging and stick breakpoints everywhere in the socket.io source code that said close. Because, at some point when I was going to get called, I'm going to be able to trace it back. And this actually worked. It took me a long time to turn all the breakpoints off later. But it's probably a better way of doing that. And basically, the issue was that the old WebSocket was being swapped out for a new WebSocket when the client reconnected. And this was supposed to build in one at a time, but reveal.js is being broken. So the old WebSocket's heartbeat does not get properly cleaned up. And the old heartbeat happens a minute later. The disconnect heartbeat gets executed. So then it kills the WebSocket, the new WebSocket that's there. And then the new WebSocket's like, oh, hey, I got disconnected. I better reconnect. And then its heartbeat timeout doesn't get cleaned up. So then every 60 seconds, when the heartbeat timeout finally times out, it kills the WebSocket, starts over again. So we actually had some cases where there were, this happened to people had flaky enough internet that they they were getting disconnected 4 or 5 times per minute, and so like there would be a timer at like 4 seconds, 8 seconds, 30 seconds, 42 seconds, and it would just like keep killing over and over again. So it was bad. It was a bad bug that was affecting quite a few users. And so the fix was basically just, I mean, this is an absolutely terrible fix because like I didn't actually fix the heartbeat timeout or whatever. But like basically I just wrapped the thing that calls a heartbeat timeout to make sure that it's actually closing the socket that the heartbeat timeout got fired on. And it worked. What? Are you kidding me? Just a second. This is like cached or something, I swear. There is literally a graph in here, and I saw it like 10 minutes ago. Yeah, I'm gonna Wireshark this real quick. I don't know why. Oh, they're 0 indexed. Yeah, it's probably also Flaky Internet. Hey! Did I have another graph that was just like said graph and didn't, like, there should have been other graphs. Anyhow, so we deployed this and it was up around 30 and it went down to like 1. So, so it was really obvious when it happened because we had these graphs here. So my point about graphs is a good one, I think. Anyhow, sorry about that. Basically, I came up with a few life lessons after this 2-month run around with this bug. Like, I added a lot more graphs so I could see what was going on all the time. I logged all sorts of, added a bunch more logging about events that were going on so we could trace future issues. I have been much more willing to just pull my Ethernet cable out instead of trying to figure out iptables when I'm trying to chase down a nasty bug. I also meant to go back and figure out how to actually do it in iptables, maybe later. But most importantly, I learned to listen to my users more because they definitely use this a lot more than I do. We're up to 900 concurrent connections at peak now, so there's 900 more people than me using it. And that's it.